You know that one document in manufacturing, the one that's supposed to predict every possible failure before it ever happens? Well, what if most of the time it's just gathering dust in a binder? Today, we're going to talk about Reverse FMEA and how it transforms that static, forgotten document into a powerful, living tool that actually stops problems on the factory floor. All right, let's get right into it. To really get what Reverse FMEA is all about, we first have to talk about the broken promise of the Standard Failure Mode and Effect Analysis, or FMEA. It's supposed to be this incredible tool for sniffing out potential problems in a process way before they ever become a real headache. Now, in a perfect world, your FMEA is a living document, right? It's supposed to be something you're constantly looking at, tweaking and updating to match what's happening day to day. But let's be real for a second. How often does that actually happen? And that, right there, is the broken promise. The FMEA is sold as this dynamic, always current risk assessment tool. But the reality? For a lot of folks, it's a check-the-box exercise you do for an audit. You create it, you file it away, and it never sees the light of day again, which means it's not preventing any real-world failures on the shop floor. This gap between what's promised and what's actually happening has gotten so bad that the big players in automotive, we're talking Ford, GM, Renault, are now basically demanding a fix. They're writing a solution right into their customer-specific requirements. They want a much more active, validated way to handle risk. So what is this active, validated approach that the industry is clamoring for? Well, the solution has a name, and it's called Reverse FMEA. At its heart, Reverse FMEA, or R FMEA for short, is really a structured way to keep improving. It's all about making sure your original FMEA isn't just a fantasy by going to the source, right to the shop floor, and seeing what's actually going on. And this is a huge shift in thinking. You're moving away from a purely theoretical exercise, predicting what might happen, and into a hands-on, reality-based check of your quality controls. So how does this actually work? What do you do? Well, while there isn't one single global standard for Reverse FMEA, pretty much every approach boils down to 5 essential steps. Let's walk through them. It's a really logical loop. First, you head out to the floor and see the process with your own eyes. Then you check if the controls you thought would work are actually effective. Here's a key part. You actively hunt for new ways things could fail that you didn't think of before. Then you double-check your risk ratings. That's your severity, occurrence, and detection, or SOD ratings. And finally, you update everything. That's the core of a Reverse FMEA audit. But here's the thing. Just doing a periodic audit, even a really good one, still doesn't make it a truly living document, does it? The real game changer with Reverse FMEA is when you weave these steps into your daily operations. And this quote just hits the nail on the head. The ultimate goal is to get the FMEA to do what it was always meant to move from some scheduled, once-in-a-while review to a constant, real-time feedback loop. Okay, so how in the world do you create that loop? Well, the secret link, the bridge between that FMEA binder and the shop floor, is something called an OCAP, an out-of-control action plan. Think of the OCAP as the operator's playbook. It's a simple, pre-approved list of known problems and the exact steps an operator should take when a process goes haywire. It's their first line of defense, right there in the moment. And this is where the magic really happens. Imagine this. An operator sees a problem, but the cause isn't on their OCAP list. So they escalate it. The FMEA engineer comes down, investigates, and realizes, whoa, we've just found a totally new failure mode we never even thought of. They add it to the main FMEA. And, crucially, they update the OCAP for everyone. You've just closed the loop in real time. Now that feedback loop is awesome for finding new failures. But what about making our risk assessment for the failures we already know about way more accurate? We can use live data, specifically from Statistical Process Control, or SPC, to verify the occurrence rating, the O in our risk analysis, with cold, hard numbers from the floor. So, how do we stop just guessing at how often a failure might happen? How do we move from a subjective gut feeling to a real data-driven rating that we can actually stand behind? We use the industry standard AIAG table. This is basically a cheat sheet that directly connects the percentage of parts predicted to be out of spec with a specific occurrence rating from 1 to 10. So let's run a quick example. Let's say your live SPC chart, which is tracking your process variation, is predicting that 0.9812%, so just under 1%, of your parts are going to be out of spec. You just look at the table. That percentage is a little less than the 1% mark. And to be safe, you always round up to the next highest risk level. So boom, the data tells you to use an occurrence rating of 7 in your FMEA. No more guesswork. So when you put all of this together, you've got the continuous feedback from your operators and the data-driven validation from your SPC charts. I mean, the payoff is just enormous. It totally transforms how your entire quality system works. That FMEA is no longer a static file in a dusty binder. It becomes proactive. It catches failures the moment they appear. It's data-driven, with risk ratings that reflect reality. It's incredibly efficient because it's just part of the daily workflow now. And finally, it becomes what it was always supposed to be, a true living document. So that really leaves us with one last big question to think about. You have to ask yourself, is your process truly in control, or are you just getting really good at documenting its past failures? The difference between those two things? Well, that's the difference between a traditional FMEA and a living, breathing reverse FMEA process.